A very good afternoon to everyone present here. Today, our topic of discussion is anaerobic digestion of solid waste, and the presentation will be presented by me, Rudranil Ghosh, Shibangi Karmakar, and Monish Paul. Let's have a look at the content of today's presentation. First, we're going to get a brief introduction and overview on anaerobic digestion, then different stages of anaerobic digestion, then biogas and its application, then classification of anaerobic digesters, and lastly, some advantages and drawbacks of anaerobic digestion. So what is anaerobic digestion? It is nothing but a natural process which occurs when organic material is kept in the absence of air. Thereby, the organic material is transformed into biogas and a renewable and green energy source. In developed countries, this process has been evolved over past 20 years, resulting in more and more complex large-scale biogas plant, including heating and multiple stages of processing. Here is a pictorial representation of anaerobic digestion. Firstly, different kinds of waste are collected from livestock, crops, and water and food wastes. Then these wastes are processed into digesters to form biogas and digested. And further, biogas is produced to obtain biomethane, which is a very clean fuel mainly used in power grid. Then we are going to look at different stages of anaerobic digestion. The process of anaerobic digestion takes place through four successive stages. First, hydrolysis, then acidogenesis, then acetogenesis, and lastly, methanogenesis. First is hydrolysis. Biomass is made up of large organic polymers. For the bacteria in anaerobic digesters to access the energy potential of the material, these chains must be first broken down into their smaller constituent parts. The process of breaking these chains and dissolving the smaller molecules into solution is called hydrolysis. Hydrolysis has its own and optimum temperature, which ranges between 30 degree and 50 degrees Celsius, with the optimum pH of 5 to 7. Therefore, hydrolysis of these high molecular weight polymeric components is necessary first step in anaerobic digestion. Through hydrolysis, the complex organic molecules are broken down into simple sugar, amino acid, and fatty acids. The next step is acidogenesis. In the acidogenesis process, the biodegradable material like fat, protein, and bacteria are further decomposed by the fermentation bacteria. As a result of the acidogenesis process, volatile fatty acid, carbon dioxide, hydrogen sulfide, and ammonia are produced. In this second phase, the concentration of the products generated must be balanced to maintain a stable and efficient process. The process of acidogenesis is similar to the way milk sours. The third stage of anaerobic digestion is acetogenesis. Here, simple molecules created through the acidogenesis phase are further digested by acetogens to produce largely acetic acid as well as carbon dioxide and hydrogen. Due to the presence of hydrogenotrophic methanogens, hydrogen is able to rapidly consumed while maintaining hydrogen partial pressure at the level favorable to acidogenesis by creating an exergonic reaction. Next, the last step is methanogenesis. The terminal stage of anaerobic digestion is the biological process of methanogenesis. These components make up the majority of the biogas emitted from the system. Here, methanogens used the intermediate products of the preceding stage and convert them into methane, carbon dioxide, and water. Methanogenesis is sensitive to both high and low pHs and occur between of pH level 6.5 to 8. The remaining indigestible material the microbes cannot use, and many dead bacteria remains constitute of the digestate, which is a great form of manure. And now I would like to call Shivangi to take it from here. Over to you, Shivangi. Thank you.
Thank you, Rudranil. Now we are going to talk about biogas. So, what is biogas? Biogas is a mixture of gases, primarily consisting of methane and carbon dioxide, produced from raw materials such as agricultural waste, manure, municipal waste, plant material, sewage, green waste, or food waste. It is a renewable energy source. Biogas is produced by anaerobic digestion with anaerobic organisms or methanogen inside an anaerobic digester, biodigester, or a bioreactor. Biogas mainly consists of methane 50 to 75%, carbon dioxide 25 to 50%, nitrogen less than 7%, oxygen less than 2%, hydrogen sulfide less than 1%, and ammonia less than 1%. Now, here are some uses of biogas. It is a biogas can be used for the production of electricity, fed into appliances for cooking fuel. It can replace compressed natural gas for use in vehicles. It can be used in instruments used for water treatment, water heating, space heating or room heating, etc. Purified compressed for vehicle fuel, compressed natural gas. Further compressed for easier and more efficient use. Liquefied natural gas. It can be used in hydrogen fuel cells as well. Production of biogas produced a very useful dry solid byproduct which is used as manure. So our next topic is anaerobic digesters. Anaerobic digesters are simply an enclosed structure where anaerobic breakdown of manure organic matter takes place. The anaerobic microorganisms convert the organic matter into biogas, which then can be captured and utilized for energy as a flammable gas. The classification of anaerobic digesters are passive systems, low rate systems, and high rate systems. Passive system is classified as covered lagoon digester, low rate system classified as complete mixed digester, and high rate system classified as fixed film digester. Now over to you, Monish.
Thank you, Shivangi. Now we are going to talk about covered lagoon digester. In this kind of anaerobic digester, reactor design that is made up of a lean pit and a flexible plastic cover. This system captures biogas under an impermeable cover while taking advantage of the low maintenance requirement of a lagoon. Now I am talk about some advantages of covered lagoon digester. It is inexpensive. It is easily adapt to hydraulic flushing. It has simple construction and management. Here are some disadvantages of covered lagoon digester. Poor mixing, poor energy yield, solid settling reduces usable volume, limited to warm climates since digestion depends on temperature. The figure 1 represents the covered lagoon digester and the figure 2 represents the schematic diagram of covered lagoon digester system. Now we are going to talk about complete mixed digester. In this anaerobic digester is basically a tank in which manure is heated and mixed with an active mass of microorganisms. Incoming liquid displays volume in the digester and an equal amount of liquid flows out. Some of the advantages are it is efficient, good mixing, good solid degradation, and it can digest different level of dry matter content. Some of the disadvantages are no guarantee on how much time the material spent in the tank. Mechanical mixing requirement. The figure 3 represent the complete mixed digester and the figure 4 represent the schematic diagram of the complete mixed digester. Now we are going to talk about fixed flame digester. In this kind of anaerobic digester is basically a tank. In this kind of anaerobic digester is essentially a column packed with media such as wood chips or small plastic rings. Methane forming microorganisms grow on the media. Manual liquid pass through the media. Some of the advantages of these fixed flame digesters are it is efficient, low bacteria wash out, high gas production per volume. Some of the disadvantages are suspended solids must be removed, expensive, plugging or of bacteria growth media, lower gas production due to removed solids. Here are some industrial application of anaerobic digestion. The applications are wastewater treatment plants, pharmaceutical industry, municipal solid waste management, food and dairy industry, and chemical industry. Some of the environmental benefits of anaerobic digestions are eliminates of malodorous compounds, reduction of pathogens, deactivation of wheat seeds. Some of the energy benefits of anaerobic digestions are net energy producing process, biogas facility generates high quality renewable fuel, surplus energy as electricity and heat is produces. Some of the economical benefits of anaerobic digestions are transforms waste liabilities into new profit center, time devoted to moving, handling and processing organic waste is minimized, adds value to negative value feedstock. As anything in the world cannot be perfect, there are some drawbacks of anaerobic digestions as well. It has slow startup process, production of explosive gas, close monitoring required, extreme confined space hazard, sensitive to temperature load and toxicity. Heating, mixing, gas collection equipments and plumbing adds cost, complexity. Cleaning and maintenance difficult with sealed tanks. And lastly, it is our humble pleasure to present our deep sense of gratitude to Professor Soumyajit Ghorai for his great and needy help in the completion of this presentation. We express our thanks and gratitude to him for giving us this golden opportunity. Thank you, sir. Thank you, everyone.